Okay, here we are again. Hi, everyone. We're in my house. You can see my house in the background. Really, that's not my house. Does anybody know what movie that's from? See if you can figure out what movie that's from. One of my favorite movies. So anyways, we are going to talk about the next chapter, chapter 2.2, which is called power functions. And power functions are about identifying a graph and identifying what kind of power function it is. And I'll show you what I mean. First of all, a power function is something like, this is a power function because it's x to a power. Here's another power function, right? You know these, f of x, x to the n is a power function. We also have ones like x to the minus 1. We have x to the minus 2, a power function. We might even have f of x equals x to the 1/2, which is the same as square root of x. X to the 1/3, which is the cube root of x. All of these are power functions. The general form of the power function is c times x to the n, where x to the n is the power. It's a pretty ugly arrow. And this is the constant of variation. And there's some interesting things about the constant of variation. If the constant of variation is positive, then nothing happens. No reflections. But if the constant of variation is negative, then this means we have a reflection. If you remember when we talked about this in chapter 1, about the x-axis. And this is important. If you got a negative number out here, then really this function is flipped over around the x-axis, okay? Now, in general, there are 4 kinds of power functions. I could, let's see if I can move this thing so I can see it. And there we go. Okay, you could have a line, okay? Could have a slope of 2, a slope of 1, a slope of 12, but it's a straight line. And then you can have, see, I'm not gonna try to make a curve, so let's turn that off. And are we back to pen mode? Yes, we are. Okay, then we could also have, let me look at my pretty picture so I don't mess it up. Oh, let's change color. We'll go to dark green. It's gonna be a lot easier. Come on. If we have these in different colors. It could be something that curves like this, or like this, depending upon if there's a reflection or not. And this point right here goes through the point, let's put this in black, death black. So this point here is always the point 1C. So C is that coefficient, y equals C times x to the n. Okay? C is that coefficient there. And likewise down here, you'd have the same thing. That point is the point 1C. But in this case, C is negative. Otherwise, you wouldn't be down here. So C would be negative down there. Whoops. Now let's go to dark majestic purple. You can also have a function like this that passes through the same point And actually, these two, the green and purple curves, are exactly symmetric around the red line. I didn't draw it so good. So that's a third curve. And then we need one more color. How about bright orange? And the fourth curve is going to be a curve that I didn't save enough room. Goes like this. It's asymptotic. It approaches the y-axis. I can't see it there. Let me make a better picture. It's like this and like that. So it slowly approaches the x and y axis, but never touches, okay? And these are the four curves, and they're reflected four curves that we have to keep track of which kind is which. This first one, this one is for when n is less than 0. Same thing here. N is less than 0. Everything on the bottom here, let me get rid of that. Everything on the bottom down here, oops, I don't need that. I need, go away. Okay, whatever. Everything up here is for c greater than 0. Everything down here is for c less than 0, right? Positive leading coefficient, you're on the top half. Negative leading coefficient, you're on the bottom half. Okay? Now let's look at the red line. The red line is, it's a line, so it's 2x, 3x plus 4, 4x plus 5. It's specifically for n is equal to 1. So 2x plus 9. N is equal to 1, so you're going to have something that looks like that. Okay? Now let's go to Purple Town. And for Purple Town, this is going to be, it's unfortunate. Let me get rid of this here. Let me get rid of all of that. We can't quite see what we need to see. Okay. And let me draw this out some. Whoops. That was the eraser. Sorry. Go there. Okay. So this is for 0 less than n less than 1. And the same thing up here. 0 less than n less than 1. So the purple curve is when n is a number between 0 and 1. So n is less than 1. Can't be 0 because anything raised to the 0 power is 1, and it's not really a function. It's just kind of boring. And lastly, for the green curve, this is for n greater than 1. N greater than 1. So that's for x squared, x cubed, x to the 4th. The exponent on it is greater than 1. Okay? So these are what our curves look like. And we need to keep track of what happens when n is greater than 1, when n is equal to 1, I wrote something wrong. Yeah, I did. I did this wrong. So let me, I made a mistake. Sorry. So this is not right. Unless, no, that is right. Okay. I was right. I thought I made a mistake, but I didn't. That always sounds so arrogant when you say it that way. So for 0 less than n less than 1, and lastly, oops, where's my orange? There's my orange. For n negative, less than 0. Okay, these are the four situations that we have. You're going to need to identify which of them they are by looking at the exponent to see what curve it is, and you're going to look at C to see, are you in the top half in quadrant 1, 2, 3, or quadrant 4? And that's your goal in this chapter, to identify what kind of graph we have here based on the form of the power function, okay? So you want to have a nice clean diagram. And let me tell you something about the brain. Boy, my nose itches. I don't know why. Something about the brain. The brain has two hemispheres, left and right. And I believe the right side is for artistic things and conceptual things and ideas, and the left side is for mechanical things, for number crunching things. Physicists like me, I live in the left side of my head. When I'm an author and I'm writing books, I live in the right side of my brain. That's the way it works. If you can put information in both the left side and the right side, your retention is going to be significantly better. There is a ton of psychological research to show this is true. Now, if you just take this picture and you just do a screenshot and say, got it. Okay, you've looked at it. You listened to me. Those are all right brain things. Good for you. If you draw this and you put it in your notes, then you're going to be more likely to remember it, because drawing and writing is a mechanical thing, and that will get it into your brain. I'll tell you, and that's why you take notes during class when you're sitting in a traditional classroom. You're listening, you're putting stuff in the right side of your brain, you're writing and taking notes, you're putting it in your left side of your brain, as well as you can look at it later. And that's an effective way to remember stuff. Now, a really great thing to do is if you take your notes and you type them, and you type up your notes after you've written them down. And what you will do when you're typing, here, let me simulate typing. There we go. When you're typing, you're reading the stuff while you're typing. You're putting it into the right side of your brain. Typing is a mechanical thing. You're putting it into the left side of your brain as you're typing, and you will find that you'll really, really, really learn that information really well. I didn't learn this until grad school, and so I got a C in every econ and psych and history class because I took notes and I never went back to look at them, and I was not a good student. And so I didn't learn that secret of that's a really powerful way to study. So you should try that. It has nothing to do with math here. You're not going to type this up, but you should draw your own picture to get that burned into your brain a little better. Okay? End of Be a Good Studier sermon. Okay. Y equals, let's do a better color that's easier to see. Maybe we'll do blue. Okay. Y equals 2x to the minus 3. 2x to the minus 3. Well, let's see. That's cx to the n, and that's n is less than 0. So that's the curve like this, and we're in the positive side. There's actually a mirrored curve over here, but we're only going to be concerned with positive values of x. And so we're only going to look at the first or the fourth quadrant. We're not going to worry about the mirrored side there. And this also happens to be an odd function, because if I put in, so I got f of x is equal to 2x to the minus 3. If you recall, if it's an odd function, then I should get minus f of x. So let's see, if I put in minus x, so 2 times minus x to the minus 3, what's that cube going to do to the exponent? So I could write this as 2 over minus x cubed, right? The negative means put it in the denominator. And with it in the denominator, that's what gives it this swoopy kind of behavior, because what happens when you put in 0 in here? It takes off to infinity. What if you put a really big number like 87 kajillion? You're going to get close to 0, but you're never going to touch 0 until you go to infinity, which we're probably not going to do since we don't want to blow up all the computers in the universe. So this has horizontal asymptotes at 0 and a vertical at 0. And when I cube this negative, the negative does not go away. It sits out front. So I could write this as minus 2x to the minus 3. And look, here's f of x, but there's a minus in front. So this is an odd function. And you're going to need to be able to identify which ones are even or odd functions. And if I ask you to demonstrate whether something is an even or odd function, this is the way you would do it. you would plug in negative x, and you look to see what happens to the negative sign when you act on it by the exponents. And maybe they cancel because it's x squared and the negative sign will cancel. Maybe they don't. I don't know. Okay, so this is the kind of graph we have. These are actually, I think they're relatively easy if you can remember the 4 curves in the top and the 4 curves in the bottom. F to the x equals minus 0.4 x to the 1.5. Okay, what's that going to be? Well, let's see. Minus sign means we're going to be in quadrant 4. 0.4, I don't really care about that number. The minus sign tells me what it's going to do. It's going to give a little bit of a vertical shrink a little bit, but we're not looking for that. We're looking for the general shape of the function. N is greater than 1, so it's going to be one of these, like a parabola facing down. Okay? Let's try another one. And when I ask for even or odd, we're probably going to do the easier ones. They're probably not going to do even or odd. So minus x to the 0.4. What's that going to be? Minus, so we're at the bottom half below the x coordinate, the x-axis. The coefficient is less than 1, so it's going to be one like this. Right? Look at the picture we drew. Look at the picture you drew, and you can see this one is there. If we had, oops, let's do it in a different, oops, where'd it go? There it is. Let's do f of x equals x squared. Let's see, let's follow the rules. So the coefficient is 1, which is positive, so it's in the upper half. X is greater than 1. It's going to be like that. Okay. F of x is equal to square root of x. Well, that's going to be x to the 1/2 plus 1 out front. We're in the top half. N is less than 1, so we're going to be on that one. We're never going to say draw this one and then draw f of x equals cube root of x and compare the two. We're not going to do that, right? I don't even know. I'm guessing it would be more like that. It'd be steeper, maybe, but I'm not really sure. But we're not going to do that. We're not going to compare these two. And the fact is, you could just plot those in Symbol Lab. And you could see, and if you were going to plot this in Symbol Lab, you would do x caret 1/3. You got to put 1/3 in parentheses. Otherwise, and this sign caret, which is above the 6 on your keyboard. Means exponent. That means exponent. And what follows next is an exponent. And if you do this, what you really wrote was x to the first power over 3, because it's going to look at the next number and say, aha, there's my exponent, because exponents always get done first. And then it'll assume that divide by 3 is for everything else. So you always need to put exponents when it's not a single number in parentheses like this. So square root of x would be x caret 1/2, like that. Got to do the parentheses if you do this. Okay. That's really about it. That we're just trying to identify which of the curves it is so that you can recognize what they are when you see them easily. Okay. Come to office hours. We'll do some more sample problems there if you need help. And there you go. Have a good day.